The conditions on the early Earth, when life started to evolve, are still more or less comparable with these extreme environments. So one of the most important key conditions to make life possible was the availability of free energy. But there is also another key condition, and that is water itself. Life, if possible, is possible on Earth because the water itself. Does anybody, it's an easy question, but we are so familiar with it that you might not think about it. What is, if you look at water, why is water unique if you compare it with other chemical elements or chemicals? And if you, what is the condition of water when it is when is water the most heavy, in its most heavy condition? Do you understand what I mean? You have, and you look at an element, you have a solid stadium, you have a liquid stadium, and you have a vapor stadium. So, and in that sense, water is unique.
It has the highest density in terms of 3.98.
Yes, yes. The highest density is at 3.9 degrees, and it's the only chemical element that does that. And that's very important. Here you see water is weird stuff, so to say, that's true. And that is very important. So water from about 4 degrees Celsius is the most heavy. And that's important because in the earliest, I have a slide later where you can see it, but in the beginnings of the Earth, when life was already there, so let's say between 3.5 billion years and 500 billion years ago, the ecosystems has to establish. There was no real equilibrium yet, like we have today, and there were crises in the planetary system, like exploding asteroids, ice ages. Perhaps you have heard of the so-called snowball Earth. You have heard of the snowball Earth. So there were crises concerning the Earth itself, and if in the stadium of the snowball Earth water would not have this property, then there would be no life, because everything would have frozen to death. That's why this property of water is so important. So, are there any conditions on Earth where we can see something about, where we can imagine how life evolved? It's of course theory, because that's about science. Something is true until it is proven otherwise. That's how science works. For instance, if we find a rabbit, a skeleton of a rabbit in a Carboniferous forest, in Carboniferous rocks, then we can heat the fire with the Book of Darwin. So you can always falsify science. It's true as long as the opposite has been proven. So, considering that, there is also a theory about how life could evolve. And a model for that is the so-called lost city of white smokers. I don't know if you have heard from it. Yeah, you know it? You're familiar with it? Okay. Before I forget it, if you are interested in this, there are two very interesting books written by Nick Lane. The one is called Life Ascending, and the other one is The Vital Question. That's a very nice title for a book about the origin of life, The Vital Question. And these are very interesting books, and Nick Lane is talking about these phenomena, the lost city of white smokers, and they are present in the Atlantic Ocean, where material is coming from the inner Earth, so where these chemical reactions at certain points still take place. So, I have another picture, because perhaps you know there are also so-called black smokers. Black smokers and white smokers are close to each other, but the black smokers are far too hot. This is a picture, you will have that available later, but you see that at a black smoker, here, oh, you don't see the arrow when I move it, huh? No. But yeah, you see it here, the black smoke? Okay. Okay. There you see it's 350 degrees Celsius, so that's quite hot. But in that process of material that's coming to the surface of the ocean floor, there are also side branches, which there is set 2 to 60 degrees Celsius. So it's beside the black smoker, there is another place where these white smokers are. And there, these so-called chimneys are made of calcium carbonate, which is available. So what you have is that you have a structure. I will go back to the. You have a structure of these white chimneys, so to say, these white smokers. They consist of calcium carbonate which are porous, so there are tiny holes in it. And because this water from out of the earth, which is coming out and reacting with the carbon dioxide, so that is to say the mineral composition inside such white smokers and the concentration of chemicals inside that white smoker is different from the ocean water. So you have an energy flow, a potential difference, an energy flow and a difference in ions available outside this white smoker and inside that structure, and it is porous. So there is an energy flow available. And that's very important because that's about cells. Also our cells have a permeable cell wall. And the structure of that white smoker looks something like this. You're familiar with this. So in a way you can compare it with this. And the interesting thing about this is that the structures, the holes in a white smoker, in that calcium carbonate structure, have more or less the size of cells. So you can consider that these structures in these white smokers, looking like this, were the matrix of which a cell could be made. These, in the primordial stages of life, the first forms of life, where the reactions already took place, where energy was coming out from the reaction between hydrogen and carbon dioxide. So the energy flows which are characteristic for life are already taking place because of the difference in composition of the ocean water and the water and the minerals inside these bubbles. So the energy flow outside and inside that medium were already there, like it is going on in living cells. But if you have energy available, then this is, and if you can use energy, that's a certain stage for life. That's also a condition to make life possible. But there is one important other condition to get real life, because this system you can produce energy, but in the same moment it's gone. You need something else to get real life. What do you need to be able to do with energy? It's also a simple question. It's so logical that you will not think about it.
What energy?
You need to be able to store it.
Yeah.
And you need to be able to store it and to use it when it is necessary. So you need. Okay, thank you. You need an accu. You know, I don't know if the word accu is also English. Is that Ella?
Battery?
Battery, you need a battery, thank you, so simple. You need a battery. And the battery is of course this, you know this, so I don't need to explain this. This is the battery. And how this was made, that's still a question. Where does the first adenosine triphosphate come from? But it seems, but that's out of this lecture, that the early atmosphere of the Earth and the radioactivity and incoming meteorites played a role to make these first compounds to make life possible. So there are still many questions, of course, about the origin of life. But as matter stands now, that model of the white smokers is a good model. So we need a battery, and the battery is this. If you have a battery, that's a next step to life, to real life. But we need something else too.
Source information, what to do with this energy.
Information and the ability to repair yourself. And you know how that works. That's of course this. It's also a condition of life. A precondition of life. And perhaps one of the important things is also that you make a simulation of the structure of the chocolate, so the porous structure with all the holes. You need to be able to make a simulation of that. So you need a wall that is permeable, that you can let chemicals in, let energy in, keep the electron potential difference, keep that existing, and that you do with a cell wall. So the origin of the cell wall is also very important. That's also a key condition to make the first life form independent from the black smokers. You could have life in the black smokers themselves, but for real life, which can real first cells who can leave these white smokers, they need to have a cell wall, and it's just a few